Hey folks, Mr. Dell here. We are looking at some probability, some compound probability, and trying to figure out what to do given a situation. So this is CPM's course 2, 5, section 5.2.6, specifically number 586. So it says Darnell is designing a new game. He will have 110 different colored blocks in a bag. While a person is blindfolded, he or she will reach in and pull out a block. The color of the block determines the prize according to Darnell's sign at the right. So if that person, whoever it is, if a person pulls out a blue block, they're going to get a small toy. If they pull out a purple block, they're going to get a hat. If they pull out a green block, they're going to get a large stuffed animal. So, and we know that there's 110 blocks in there with those three colors is what we have to, because there's different colors and there's blue, purple, green. So he says if he wants players to have 60% probability of winning a small toy, how many blue blocks should he have? So he wants the probability to be 60%. So what does that mean? I'll just write it out. So the probability of getting a blue block, right, needs to be 60%. Well, probability, the nice thing is to look at probability as a fraction. So I'm going to convert that to be a fraction 60 over 100, correct? So I know 60 out of 100 needs to be blue in order for me to have that. So we know that there's 110 though. So can I do something with this to get myself to figure out how many blue blocks would give me that 60%, right? So I think I can take this fraction and even simplify it further, right? If I can divide top and bottom by 20, if I divide top and bottom by 20, simplify the fraction, I get 3 fifths. So I know that if he wants it a 60% chance, he wants the probability to be 3 out of 5. So now we're almost there, because if the probability is 3 out of 5 and we know that there's 110 blocks, the question is how many blue blocks would there be for 3 out of 5 to be the same as something over 110, right? Because the probability of blue needs to be 3 fifths. So if right now my total is 110, what would the number of blocks truly be that would then simplify to be 3 fifths? So we would have an opportunity here to kind of think about what fraction is equivalent to 3 fifths that has a denominator of 110. So I can look at it as, okay, maybe I can multiply by a giant 1, right? And I can, because 5 times 22 is 110. So if I multiply top and bottom by 22 over 22, that giant 1, 22 times 3 is 66. So that becomes 66. So if I want exactly a 60% chance of getting blue, then there has to be 66 out of 110. So that's my answer right there. So how many blue blocks? 66 blue blocks would be 60% probability. Okay. There's A. B. If he wants players to have a 10% chance of winning a large stuffed animal, how many green blocks? So we're going to go the same process. Now, I want the probability of getting a green to be 10%, which, again, when we think probability, putting it as a fraction, 10 over 100, simplifying that fraction to be 1/10, right? You can divide top and bottom by 10. So I want it to be 1 out of 10 to be green. But just like we did up here, we know that there's 110 blocks total. So what's going to be my number of green blocks to make that a equivalent fraction to 1 over 10? Well, I can multiply by a giant 1, right? 10 times 11 is 110. So my giant 1 is 11 over 11. And so therefore that number there is 11 when I multiply 1 times 11. So this one would be 11 green blocks for 10% probability. Okay. Probability. There we go. All right. There we go.